Right, so welcome back. We've nearly finished the topic we're looking at, but we need to kind of drill down and talk about some of the specific components that we've looked at in previous lessons and how they are affecting the performance of your computer, so how fast they're completing tasks. So if we start by looking at this diagram again, we've got our main components here. So we've got the CPU. Now that's responsible for the fetch, decode, execute cycle, and that is your tasks being completed, whether that's opening a program, coding a program, whatever it is, the CPU will be allowing that to happen. So that has a big impact on the speed of our computer. So we'll have a look at how exactly in a sec. RAM we're not too bothered about. Yeah, it holds our BIOS, make sure we can load our computer up, but other than that, doesn't particularly affect performance. RAM does, because remember we talked about if RAM is full, we have to take a section of the secondary storage and use it as RAM, which we call virtual memory. And we talked about this idea that virtual memory is slower because you've got to move programs into RAM before they can be part of the FDE cycle. So the more RAM you've got, less use of virtual memory. Secondary storage, we talked about, haven't we, the idea that some secondary storage has got faster reading and writing speeds than others, but other than that, it's not a huge determinator in the speed of your computer. So let's drill down a little bit. So in terms of the CPU, there's three factors that affect the speed of any given task. So we've got the clock speed, the number of cores, and the cache size. Now we've already talked about cache memory, which is fast memory located on the CPU that holds regularly accessed data. Now it's faster than RAM because obviously there's less distance for the CPU to travel to access that. Obviously the more cache memory you've got, the more data you can store there before we go to RAM. But let's have a little look at the other two. So clock speed. This is the number of instructions that your processor can carry out per second, and this is measured in hertz. Okay, now in reality, the processor can carry out billions of instructions per second, so your clock speed is obviously going to reflect that. Now, the higher your clock speed, the higher number of instructions you can carry out per second. Yes, I've put per second in bold twice because you have got to put it in your exam answer to get the mark. If you just put the clock speed as the number of instructions a processor can carry out, yeah, but over what given time? Okay, make sure you're really specific on that. Now, you might have heard this phrase overclocking, and that is where you make your CPU run at higher clock speed than the factory setting that has been set to. This is good, yeah, because you can speed up the processing of instructions per second, but in exchange for that, the potential issues are it can cause overheating, it can cause the computer to crash, or it can actually cause permanent damage to the system. So it's something to be exercised with caution. Okay, so let's have a little look at the number of cores. Hopefully you've heard these words bandied about before: dual core and quad core. Dual core means your computer has 2 cores, quad core 4. So when we've talked about our system, we've presumed there's 1 core, and that fetch, decode, execute cycle is just happening once. Now if it's dual core, you would have 2 cores, each carrying out their own FDE cycle, so twice the amount of instructions could be executed per second. Quad core, you would have 4 separate cores, so you'd have 4 FDE cycles going on at the same time. So by default, if we've got more cores, it should be faster to it should be faster to process a batch of data at any given time. And most computers now have 4 or more cores. However, not always the case. In reality, doubling the number of cores doesn't double the performance of your computer. Now, there's two reasons for this. Firstly, part of the CPU processing power needs to coordinate the activities between the other cores. So part of your processing power or part of your FDE time will be spent on that coordination. The second thing is, not all tasks can just be split up. Say you've got quad core, you can't just split whatever you're doing into 4 equal parts. If you think about your Python program, if you had a subprogram that was dependent on a piece of data, you couldn't just split that into 4, you'd have to process it in order. Like the Fibonacci sequence, that relies on the piece of information before it, so you need that to process it, so you can't just split it up. If you had 800 numbers that you wanted to add together, that would split perfectly into 4. Each processor could do 200 numbers and you could put them all back together. But in reality, very few tasks work out like that. Yeah, increasing the number of cores does increase the amount of tasks you can do at once, but not to that kind of level. And then I think we've said everything there is to say about cache. More cache you've got, more data you can store, less you need to use RAM, which is further away, so it's slower. Okay, so if you get asked about the factors affecting performance of the CPU, these are your key words: your clock speed, number of cores, and cache size. So let's have a look at RAM. As we've already mentioned, the more RAM you've got, the less likely you are to use virtual memory. Virtual memory slows things down, so your application should run more smoothly if you've got more RAM. It's also, if you've got memory intensive applications, like we were saying, the virtual machine on our school system is a huge program. It only runs properly on the computers in IT1, IT2 and IT3 because of the RAM size. It's easier to upgrade. You just take the RAM stick out, put one with a greater capacity in. Now, the only thing to be aware of is if you've already got sufficient RAM in your computer that is allowing you to open as many applications as you want and the programs are running smoothly, there's no point putting more RAM in because it won't affect the performance. It won't make the computer run any more efficiently. Okay. And then the last thing we need to look at is a new addition to our diagram. So here you will notice a GPU, a graphics processing unit, and they are specifically designed to process images and graphics. It's nestled with the CPU, so the CPU can dish anything that's graphics or image related out to the GPU to process. Now, that's good news, because if the CPU can give any image related tasks to the GPU, that relieves the load on the CPU, so the CPU can get on with something else. So it speeds up the system in that way. Now, most computers have got basic graphics processing units in, but if you really want to increase your graphics, so say you were using your computer for gaming, or you were an architect and you were using design software to design buildings, then really you want to put a graphics card in, which is a dedicated graphics processing unit. Okay, so those are the 3 ways that we can increase the performance of our computer. We've got our factors of the CPU, we've got our factors of RAM, and then we've got our graphics processing unit. This is a lovely short little unit. Rewatch the video, make sure that if any questions come up on this, you are absolutely ready to knock them out of the park. Okay?